All right, so I'm Amanda Nam, and I will be both moderating and slide driving for the next session. I think we'll just continue on to get some updates from the other divisions that are involved in Artemis, or actually all of the divisions, excuse me, that are involved in Artemis. And we will start first with Jim Spann, talking about heliophysics.
All right, thanks, Amanda. Can you hear me?
Yes.
Okay, so on the agenda, I only have 5 minutes and I've got way too many slides. So I'm going to kind of skip through some of these, but there will be available. And if you see something and you want to put a question in the chat, please go ahead and then we can pick it up later. But I don't have enough time to go through all the slides. Okay, so let's go to the next slide. And so just as a reminder, heliophysics is kind of an interesting division in the sense that it kind of captures a lot of aspects. And in fact, it's the one division that really touches all of the other science division in the sense that we study the sun, the extended atmosphere, and its connectivity with the other solar system bodies, interstellar space, as well as our own planet. So through space weather. Next chart, please. So just a couple of general highlights, and I'm not going to spend any time in this, but NASA's in the Heliophysics in the process of selecting many new missions, as well as following the missions that we've got going on, a particular Parker Solar Probe, selecting several CubeSats, including Dolly and the Minx, as well as the new mission HERMES, which I'll talk with you a little bit, just passed the KDPC in this January. Next chart, please. We've announced a couple of new MEDEXs, all of which study the extended solar atmosphere as well as the area in geospace. Certainly the sun missions are totally relevant to Artemis as we try to understand the environment in which the moon passes. Next chart, please. The space weather program, we're establishing that, and that's, you can think of that as the applied part of heliophysics. I'm not going to go over this in detail, but if you have any questions, I'd love to spend time with you talking about the importance of space weather, not only to deep space exploration, but just humanity in general. Next chart, please. And just so you know, we're planning for kind of a Heliophysics Big Year, which really covers 2 years, and I guess that's why we call it big, because it's really 2 in 1. But the point is that we have a couple of solar eclipses, which was just referenced, which really is totally relevant to the moon, as well as the increasing solar activity as we rise to the solar max of solar cycle 25. So we're going to have a lot of opportunities for the community to engage in this, both the science community as well as the public. Next chart, please. So the Artemis science objectives, at least for the Artemis 3, has been identified. I'll just point out that 4 of the 7 objectives are relevant to heliophysics as we study the sun, use the surface of the moon as, or orbiting the moon as a unique opportunity to study heliophysics, as well as conducting fundamental plasma experiments. And the applied aspect is working to understand the space environment, mitigate exploration risks to human, and I would add robotics. Next chart. As well, not only the Artemis program, but the CLPS program, 9 of the 29 payloads that are expected to be delivered over the next year or so have relevance to heliophysics. And in the backup charts, I kind of identify what those are. And if you have an interest, you can go and look at those and get in touch with me if you have any questions. Next chart. What I really want to spend a little bit more time is talking about the science from Gateway that we can do. Next chart. There is a long-term strategy that has been developed for this, and I wanted to describe a little bit about the first three payloads, the science payloads going on Gateway that are focused on the space environment, which is relevant to the surface science that can be done, but also the science that's enabled by having orbiting assets. And so the three payloads, this is an international activity. So HERMES is the NASA payload, URSA is the ESA payload. Those two are really focused on the radiation and solar wind energetic particles. And IDA is an internal dosimeter array, which is largely a partial copy of what is on the URSA payload, which is looking at radiation, both on the externally with the URSA payload and internally to the halo with the IDA payload. I'll also mention that on the URSA payload, there is a low velocity dust monitor that JAXA is providing. That's a late addition, so I haven't updated this chart yet, to really study the induced environment of the particulates and dust that will be generated by the activity on the gateway, and can serve as a baseline for future dust experiments that we would like to put on this platform. Next chart. And so the Hermes goals and objectives are really enabled by the unique environment that the moon provides as it orbits the Earth. About 75 to 80% of the time, it spends its time outside of the Earth's magnetosphere. And so looking at the transport and mechanisms of the solar wind, not only with this platform, but in conjunction with the existing orbiting platforms around the moon, particularly the Themis Artis platforms, provide a 3-point measurement system over some scale sizes that are very unique and very useful to understanding the solar wind. The next goal is really focused on the time that the moon system spins in the Earth's deep magnetotail. And so in the same way as we do in the solar wind, studying the Earth's deep magnetotail in conjunction with other assets that are orbiting the Earth much closer, we can characterize the energy topology and ion composition of the deep magnetotail. And then the last goal is really focused on the applied aspect of Hermes, which is establishing a pathfinder for on-orbit observations of space weather that will help us look toward the future as we eventually end up in Mars with humans, and understanding what sort of observation capabilities are needed for Earth-independent space weather forecasting and mitigation capability. Next chart. And so the last few charts here is really a just description of the Hermes payload. You can see that it's comprised of 4 instruments, electron and ion top hat electrostatic analyzers. Then there's a Merit ion and electron telescope. This is a solid state telescope looking at a little bit higher energy particles. And then a magnetometer. And you can see the instrument teams there. Next chart.
Hey Jim, we're about 3 minutes over. Can
Okay, all
we
right.
make the
So
last slide the next slide?
yes, just go to the last advanced 2 slides, and then I'll finish up. These are just some milestones. Oh, well, okay, the last slide there. Okay, and if you got any other questions, they're more in the backup that you can have. Okay, I told you I had more slides than I needed. Okay, thank you, Amanda.
Thank you. No worries, Jim. We're doing well with time. Thank you
Okay.
very much.